At this point, our river simulation is looking pretty cool. We have our inflow and outflow working with those gas guiding volume layers, and things are looking nice so far. However, as I mentioned at the end of the last video, we aren't really maintaining a consistent flow along the length of the river, especially in the middle section there. So we need to apply some extra force to really keep the current of this river moving along. So one option that we have at our disposal to add this extra force is to use volume advection. And even though we're doing a flip simulation here, we can use our various pop forces as well. And in this case, we're going to use pop advect by volumes. And we can wire this into the sourcing post-solve input on the flip solver. And then taking a look at the pop advect by volumes options, we have a SOP parameter to point this to a velocity volume from SOPs. This could be a basic directional volume, or another interesting use case for this tool is to take one simulation and use the resulting velocities from that volumetric sim and then use that to drive some particles or something, which can be used for some pretty interesting effects. But in this case, we don't need to do that. We just need to use it to enforce the flow direction along the length of the river. So let's go up to the SOP level to create our flow velocity volume. And we've actually already created this with our boundary velocity setup. And for the boundary velocity, this only set up a velocity volume on each of these plugs for the inflow and outflow behavior. But we can do almost the same thing for this volume advection, except that we're going to set up a velocity volume that runs all the way through the river. So I'm going to copy this volume rasterize attributes along with the nulls and the volume trail. Just copy that and paste that off to the side here. And then we can disconnect this and connect a new null above them. So connect that null to both the volume trail and the volume rasterize attributes. And for the boundary velocity, this was built based on our source particles that already had some velocity applied to them. So it's just going to be the same thing in this case. For clarity, I'll rename this null to particles with velocity, and then connect this to our source particles. So now all of these source particles that are being used to initialize the river sim are now being rasterized into this velocity volume. And as we saw before, this is just invisible at the moment, unless you turn on smooth wire shaded, where you can at least see the bounds for this. And just to make sure that it's working, let's display this volume trail here. And with that displayed, you can take a closer look and see that our velocities are following all the curves and bends of this river. So now let's rename these nulls. I'll call the boundary velocity null flow velocity. And then the volume trail one, I'll call that visualize flow velocity. As before, I'm just going to drop a netbox around this to keep things nice and clean. And now we can go ahead and add this to our pop advect volume. So diving inside the DOPNet and then going to this pop advect by volumes here, we can open our operator selector and point this to flow velocity. And one thing to watch out for is the field name here. So this is defaulting to look for a field name called velocity, but our flow velocity volume is called V, not vel. If you middle mouse on that flow velocity here, you can see that name is just V. So it's very important that this matches in the DOPNet. So back on that pop advect by volumes, change the field name to V as well. And then let's zoom in on our river, frame that up nicely, and run a flipbook to see what this looks like. Now this is looking quite successful in keeping that current flowing throughout the entire length of the river. It is kind of ruining the natural flow and behavior of our water though, so we probably want to split the difference and apply some of this flow force via that advection, but tone it down a bit so that we reintroduce a little bit more of the natural flowing behavior of the water, and so we're not so completely overriding it with this extra force that we're adding. So back on our pop advect by volumes, we can try just turning down the air resistance quite a bit. Let's try dialing this down to 0.3 to see what that looks like. Now after scaling down the air resistance on that pop advect by volumes, things are looking a bit better, and this is reintroducing a lot more of that natural water motion that we want to see. So this is looking quite good, and you could just roll with this, but let's also take a look at what it looks like if we don't treat this as wind. So we can bank this as one decent option. Perhaps you could try turning down the air resistance a little bit more and see what that looks like. But before we do that, let's see if we like the way this looks when it's not treated as wind here. And this treat as wind option will avoid overshoot in the particle's velocity, which could potentially be desirable, but that also might lead to a more tame result. So let's try turning this off and go with the standard force application, and we'll scale this force down as well to the same value as we did for the wind. I'll try a value of 0.3 once again, and I'll disconnect our previous mplay session so we don't overwrite that, and do a new flipbook to see how this version stacks up. And now this latest version of the sim is looking quite nice. After turning off that treat as wind option, this is looking much more energetic and dynamic and natural, and I'm quite happy with how this is looking overall, so we can move on to increasing the resolution of this and caching it out to disk.